Let's continue with section 5.2, monotonicity and concavity. Today we're really going to be focusing on concavity. Remember we learned about the second derivative of a graph. Visually speaking, we refer to that as the concavity of a graph. If the second derivative is less than 0, if it's negative, then we call the graph concave down. And if the second derivative is greater than 0, then we call the graph concave up. So if you think about it, these two curves are concave up. These two curves, actually, let me write it this way. These two curves are concave down, right? Note that these two curves are facing up, and these two curves are facing down, okay? Now, when the second derivative equals 0 and the graph changes concavity, then the point where that happens is called an inflection point. And it looks something like this, right? We have concave down, and then second derivative 0, and then we have concave up. So something along those lines. Or the opposite, right? We might be concave up, and then concave down, right there at that inflection point, right? And the nice thing is once we know f prime and f double prime, we can actually sketch a graph. And all we need to know is these four curves. And remember, this is the case where f prime is greater than 0, f double prime is greater than 0, f prime is greater than 0, f double prime is less than 0, both f prime and f double prime are less than 0, f prime is less than 0, and f double prime is greater than 0, okay? Now, let's skip example 1 and example 2. We'll do those in class. Instead, let's go to example 3, where I say let's sketch the graph, but more importantly, identify all of the critical points and intervals of increase, decrease, maxes and mins, and intervals of concavity, and even if there are any inflection points. So basically find all the first and second derivative information. So what we're going to do is we're going to take the first derivative, set it equal to 0, solve for x. Then take the second derivative, set it equal to 0, solve for x, and then find all the information. So we take the derivative. The chain rule is in effect here, but the derivative of x plus 1 is just 1. Right? Set that equal to 0. And know that if you're clever, you can actually factor this. Of course, we can factor out the 5, but we can also, this is a little clever here, but we can factor it like this. So if you're not quite sure how I did that, pause the video, factor out the 5 first. You're left with x plus 1 to the 4th minus 1, and you can factor it out this way. And I'm just going to put this guy in front. So we have 5x plus 1 squared plus 1, right? Because that's always greater than 0. And then here, if you think about it, if you actually multiply all that out, you get x squared plus 2x. And this factors pretty nicely. And so we get that x equals 0 and negative 2. Now, normally we would draw our interval chart, but in this case, we're just going to jump right over to the second derivative, get that information, and then draw an upgraded, expanded interval chart. Okay, now remember to make sure to take the derivative of the derivative, not of some kind of simplified version of it. So anyway, we take the derivative, we get 20 x plus 1 cubed equals 0. And that's a bit easier to work with because here we know x equals negative 1 and that's it. All right, so in this case, we're going to draw a bigger interval chart where we have f prime on the top, f double prime on the bottom. And we're going to draw our critical numbers, 0, 2. Sorry, 0, -2. They should be reversed. All right, and remember, same rules apply. If we're finding intervals of increase, decrease, just plug in one value in this interval, one value in this interval, one value in this interval. All right, so f of, I don't know, -3, sorry, f prime of -3, I should say rather, calling it f and f prime. It's really h. I should call this h prime, h double prime. Anyway, h prime of -3. Well, that's going to be positive, right? Because this is going to be positive. It's going to be a big positive number. If we plug in something like -1, we're going to get 0 minus 5, right? I'm looking at this guy right here. That's going to be negative. And then h prime of, like, I don't know, 1. Definitely positive. Remember, you don't have to write this up here. I just do to make it clear how I'm getting things. This is a bit easier, right? Plugging a number into h double prime. Oops, sorry, this should have said greater than 0. Here, h double prime of, I don't know, -2. I think that's going to be less than 0. And actually, I like to put a minus sign for each sort of symbol, each sort of interval that's a part of, or that it's above or below. And anyway, h double prime of, let's say, 0 is definitely going to be positive. Okay, so we have a plus and a plus. I just like to sort of stack the symbols when possible. All right, now let's write down all of our information, okay? Maybe I'll go ahead and move this guy. Move this guy over here. And I'll just say, okay, what do we have? H is increasing on -infinity to -2, union 0 to infinity, and decreasing on -2 to 0. Remember, we always use open intervals. H has local maximum h of -2, which equals, if we plug that in, and just do that scratch work over here, this will be -1 to the 5th plus 10 minus 2. I think we're getting 7. And local min, h of 0, and that's going to equal -2. Nope, not -2. 1 minus 2 should be -1. Okay, so that is our first derivative stuff, right? We answered, we found the critical points, right? Critical points, just to write them out. Critical points are -2, 7, and 0, -1. Okay? Critical points, intervals of increase, decrease, local maxes and mins, and now we look at the second derivative stuff. Now we're looking at this part, right? H, I guess I should say, is concave down on -infinity, -1, and concave up on -1 to infinity, with inflection point -1, and then whatever h of -1 is. that will be 3. Right, now how do I know it's an inflection point? Because we go from negative to positive concavity, okay? And just want to point out, if we wanted to sketch this curve, which we don't, yeah, I guess they did ask for it at this point. Well, I guess I should make the axes. I may not draw this exactly to scale, but something along these lines. So anyway, we know that we have a max at 7. And we know we have a min at 0. And we have an inflection point here. So if we just look at this right here, you see how that corresponds to this curve? Well, try that a little bit better. Try a little bit nicer. There we go. Right? It's increasing, but with a negative second derivative, right? That was what we had up here. Right? Now we are decreasing with a decreasing rate of change, right? Which is this. Start that a little lower. Try that a little neater. There we go. And then we have a curve where we're decreasing, but we're concave up. So this corresponds to this. And then last, we are increasing and concave up. And that's our curve. And there we go.